Yes, I'm talking about you guys in the back corner, yes. All right, good morning, class. Today we're going to be starting Unit 2.6. We're not going to finish Unit 2.6. It's at least a 2-day lesson, but we can at least start it. Now we're talking about competing function model validation. What? Basically, we're going to be looking at residual plots and things like that and revisiting the idea of what it means to be a good model. Because, you know, when we put data into the lists, when it gives us an equation, it's not always a perfect model. In fact, it's rarely a perfect model. It's going to do its best. It's going to try to get close. And we need to know how good was the model. So here we have Darren getting hurt and going to physical therapy, and these are the times he went to physical therapy and the days he was able to the times he was able to complete a repetition. The line of best fit equation has been given to us. Here it is right here, and this little symbol, we read this as y hat. It's just to show us that it's not the same as what the actual y values are. You can't say y equals because these are the y values. Cool with that? So instead of giving it a different letter, we do still want it to be a y of some sort, so we give it an accent. Put that little hat over top of it, and we say it's y hat. So y hat is the model 2 plus 05x plus 4.95. These are the actual trips, repetitions that were able to be completed. This is the scatter plot of these 5 pieces of data. Let's go ahead and verify. So stat edit, and just put those 5 pieces of data in. Let's see, our window looks like from 0 to 10 on the x, and the y-axis looks like it's going by 2s. So 22, 24, 26, 0 to 26. Window 0 to 10. Scale of 1 is good. And the y is 0 to 20. I don't want to do 24, so I'll take it up to 26 so I can see every one of the dots. Remember, in order to see your dots, go to y equals, go to y equals, and go up to plot 1 and hit enter. Now when you hit graph, you should see those 5 dots on the screen. Why does my x-axis look wrong? What'd you say? Yes?
For L1, we did 1, 2, 3, 5, right?
Oh crap, that's why. It's 1, 3, 5, 7, 9. Okay, that'll do it. That's better. I was like, yeah, something's wrong. There it is. Good catch. So now it looks right. If we wanted this line of fit, they gave us the equation, which is nice. So go to y equals and type it in. 2.05x plus 4.95 and hit graph. And you will see what they have on this image, except they use circles and we use squares, whatever. Use the line of best fit to find residuals. Sketch a vertical line at x equals 5 and y equals 18. I'm going to do that as a blue dotted line. And that is this actual x, it's this. It's that dot right there. Hopefully you can see that our line of best fit actually didn't hit that coordinate. That coordinate is a certain distance away from our line of best fit. The vertical distance, that thing I just traced in red, that is known as an error in the model. I mean, the model's not perfect, right? But since there are 5 coordinates, there should be 5 errors. Maybe. So what we're going to do is fill out all of this stuff, but we're going to let our calculator do all the heavy lifting. Cool with that? Yes, Mr. Ram. Great, great, great. So we already have x and y. Stat edit. Let's get in here. Okay. We want these values to be our y hat values. So come over to L3 and hit enter. Y hat is 2.05 times x. But where are our x values? They're in L1. So we're going to say second L1. L1 is right above the 1 there. So when you tell it to do this, it's going to take every entry from L1 and multiply by 2.05 and then plus 4.95. Then when you hit enter, it'll show you the predicted, using a little bit of vocabulary there, the predicted y values. Those go here. The residuals are found by taking your actual y values and subtracting your y hat values, your predicted y values. So a residual is actual minus predicted. And again, we're going to let the calculator do the heavy lifting for us. Go up to L4 and hit enter. And you're going to tell it to do your L1, because that's where your actual y's are. Till L2, sorry. I did that in first period, second period also. Yeah. Your actual y values is L2 minus your predicted y values, which was L3. Remember, L2 and L3 are right down there by L1, second. And then when you hit enter, it's going to populate that list for you. Ta-da! 0, negative 1.1, 2.8, negative 2.3, 0.6. I went up to L4, I hit enter. I went up to L4, I hit enter, and I told it L2 minus L3. That way it's doing actual y's minus predicted y's. Notice there is something new here. The sum of these. Could we grab a calculator and ask it and add up all these numbers? We could, but remember what we're doing here? We're letting the calculator do the heavy lifting for us. This is new. Come down to this blank. We wanted to add these things. So we go to second stat, but this is not in operations. This is not a list operation, so to speak. We're asking it to do math within the list, not to the list. So you come over to math and come down to sum. You don't have that? Did you come down to here? No, second stat. Here, let me clear it out. Second stat, over to math. Yep, and then come down to sum and hit enter. And you're going to tell it to add up L4. Whoa, L4 adds to 0. New knowledge. If the sum of your residuals is 0, it's a good model. And that should make a lot of sense to you, because if you remember back to sometime in chapter 2, we were talking about how a good residual plot is relatively scattered above and below the x-axis, meaning some are positive and some are negative. So the closer you can get to a residual sum of 0, the better. It's pretty good. That's a good model. In fact, if we were to do the linear regression, this thing's R value is 0.958 or something like that. So it's a really good model. It's really good. This one, though, I'm going to come here to L5 and hit enter. And you know what I want this thing to do? I want it to square the numbers that I had in L4. So you just do L4 squared and hit enter. And that worked perfectly except for the sum. Because when we squared all these numbers, they became positive. There is no way they added up to 0. That's impossible. So we're going to have to delete that entry and do the second stat math sum again. This way it sums L5. Second stat math sum of L5. they add to 14.7. So it's going to come up later in the notes, but someone in second period was like, yeah, so what does this do for us? Why did we bother doing that? Well, you've heard me call it the line of best fit. Its official title is the least squares regression line. So what it does is it takes all your residuals, squares them, and adds them, and then it finds the model that minimizes this number. So it's called the least squares regression line. So the closer this number is to 0, the better the model is. Because that meant all your residuals were ridiculously close to 0. So this minimizes the sum of the squared residuals. So we call it the least squares regression line. Okay? It's a whole course on regression in college, regressional analysis. Some vocabulary for you. Psst, hey, don't have time for this. Vocabulary for you. Y bar means the average Y value. So the deviation of a data point is how far it is from the mean, how far it is from the average. We call that the deviation. The residual is how far it is from the predicted value. Okay? Residuals help us figure out if we have an appropriate model. Difference between the predicted and actual values is the error. So what do we have? We have regression, line of best fit is the least squares regression line. I've already explained that. A residual is actual value minus predicted, whereas the error is just the predicted minus actual. I'm not ever going to be like, oh, what was the error? Ha, gotcha, you found the residual. No, I'm not going to do that. That's just mean. There's no reason to do that. So what do we have? A whole new set of information. And if you follow this order, if you follow these directions in the wrong order, like I did in period 2, it's going to be a colossal train wreck like it was in period 2. So please read the directions and follow them in the correct order. First thing we need to do is reset all of our lists. You could clear them all one by one, or you could do this. Second, plus sign, which is the memory menu. And you'll notice number 4 says clear all lists. 4, enter. There, my lists are clear. Stat, edit. See, clear lists. Or you can clear them one at a time. I'm going to go ahead and enter these. That one actually is 1, 2, 3, 4, 5. Cool. We are going to find the residuals without having the line of best fit. In the last example, we were given the line of best fit. Now, we could find the line of best fit. It's possible, but we don't need to, as long as you do this in the correct order. We've entered L1, we've entered L2. It says press second Y equals. This takes us into our stats plots menu. While we're here, we're going to choose plot 1 and hit enter. Clicky. And we're going to turn it on. So make sure on is highlighted and hit enter. Mine is right now by default from last period, I guess. Now we're going to arrow down to where it says type. We're going to choose the first option because the first option is scatterplot. Great. We want the X list to be Y1, but we want the Y list to be our residuals. And so this calculator will tell us the residual values on the plot without ever having the line of best fit. And here's how. Second, stat, and then residual. It says 9, but on my calculator it's not 9. For me it's way, way, way at the bottom. But second, stat, residual, hit enter. And then we're going to graph it. Oh no, I did it again. What is this invalid dimensions that it keeps throwing this error? Why does it do this to me? Okay, for some people it does it, and for some people it doesn't. Is there anybody's calculator that didn't throw that error? Yours doesn't count. Yours is a Casio. I'm going to do zoom fit and see if that fixes it. Invalid dimensions. That didn't fix it either. Oh my gosh. Okay, well, I do know that if I go to stat, calc, lin, reg. No, that doesn't matter. If I go to lin, reg, and I tell it to calculate the linear regression, it will. And now when I hit graph, it'll work. I don't know what that is. Oh, that's the thing from the last question. So why did it, see that time it didn't throw the dimension error. I don't know why. You're not supposed to have to do that lin reg thing, but for some reason it's making me. I don't understand. But anyway, the reason why we're not seeing this picture is because my window is way off. So I'm just going to adjust my window to this size. So go to window, and I don't need negative x's. So I'll just go from 0 to 1, 2, 3, 4, 5, 6. 0 to 6. Scale of 1. Y minimum, negative 1, 2, 3, 4. They went to negative 4, whatever. Y maximum, positive 4. Now we have that image. So if it said error, dimension, whatever, just actually do lin reg, and then don't even worry about it. I don't know why it's doing that. Yes? Well, all I know is that it doesn't need to be the second plot. That's all I know. I don't know, because I did lin reg, and there it is. I just counted. 0 to 6, and then plus or minus 4. Great. So that's what it looks like. But if you want to know the actual residual values that it just plotted, then go back to stat edit, up to L3 and hit enter. And then you do the second stat resid thing again. Second stat resid, and hit enter. And there's the numbers. So 0.4, negative 1, 0.8, negative 0.2, and 0. I just went to stat, up to L3, hit enter, second stat, resid, okay? There they are. That's if you actually wanted the numbers. So I don't know why. I don't know why. I'm going to be real with you. To be honest with you, I think it would be even better to go here first, build the residuals, and then just go to your stat plot. And instead of telling it to do the residuals, just tell it L3. Like, that would have been a much smaller headache. See how easy that was? If we had just gone to here first, told L3 to be the residuals, and then plotted L1 versus L3 instead of goofing around with the resid. Yeah, I think this is some baloney. I don't think this works. I think it's missing directions. I went to stat, edit, up here to L3. Here, I'm clearing it, okay? Watch. Enter, and then that's where you do the second stat resid. And it'll spit them out. And then in the stat plot menu, don't bother graphing residuals. Graph it as L1, L3. I don't like these directions. They're trash. When you did what? Be more specific. Because you never did the lin reg, did you? Oh, jeez. All right, give me a card. Come on. Quick. Enter, stat, no. Enter, second stat, resid. Why is it doing that? What in the heck? I hate everything about everything right now. Stat, calc, lin reg, sure. I don't know why that's doing it. Stat, edit, enter, second stat, resid, enter, there. I don't know why it wants the linreg, but it does. I don't know. I don't know why. You're not supposed to have to do that, but it wants it. Whatever. Honestly, I would never bother with residuals without a linear regression anyway. What's the point? What's it plotting the residuals of? It needs the linear regression. This is review. Nice random dots, nice random residuals. Es bueno. Form a pattern or another pattern. Boo. Okay? You don't want that. All right? That's old stuff. Here we have a least squares regression line, a line of best fit, and some actual y values. We're going to draw, with me, red. I'm going to use a red pen to draw line segments from our actual data value to the line of best fit. Because that's a residual, that's a residual, that's a residual, so is that. That one doesn't look like it's going to have one. That's a residual. So all of those little red lines have a value. And those values, it says, what do they tell you? What does it tell you about the value of the residual? Well, if it's above, the residual is positive. If it's below, the residual is negative. Above equals positive residual. Below equals negative residual. And look, there it is. There's the first positive one, then there's the negative one, there's the positive one, there's the negative one. Oh, I guess that one is slightly below, a slightly negative residual. And then the last one that was above. See? So how do we know if our predicted line overestimates or underestimates the data? The sign of the residual. That's how. The predicted line will blank data when the residual value is positive. If the residual value is positive, that means the actual dot was above your line. That means your line underestimated. And if you have a negative residual, like here, that means the actual data point is below the predicted line. So the predicted line is overestimating. Oh, that D shouldn't be there. The predicted line will underestimate data when a residual value is positive. The predicted line will overestimate data when a residual line is negative. When a residual value, is negative. So it's just a lot of information and how to use your tech, okay? Okay, we might actually make it. We might actually make it. Suppose we have these data, or suppose that these data have been measured for two related variables, x and y. It says enter the data in two lists on your graph calculator. So you've got your x list, you've got your y list. Show by linear regression that the best fitting line is this. So we're going to actually type these in as x comma y. Be diligent, make sure you type it appropriately. And I'm going to do clear, enter, clear, enter, clear, enter. Or I could have done second, mem, clear entries, whatever. I was just double checking to make sure I typed them in right. We're going to go ahead and do linear regression on that. So stat, calc, linreg. Please make sure you have x list as L1, y list as L2, and nothing else in there. If you wanted to store the regression equation, you could, but I don't really see a reason to because we're not going to actually plug anything into it. So I'm just going to hit calculate. And it generated a linear regression for me. And I could see that it's got a 0.987 R value. So that is going to be a really good model. my residual points should be pretty darn small. Stat, edit, and my y hats. Oh, crud, I cleared it, but that was it. 1.52x plus 2.35. I cleared it. Sorry. That's what it said, though. Okay. Now what we want is we want to generate our y hat values. Right? Oh, you know what? What if we didn't have the equation and we wanted this to do the heavy lifting for us? Stat, calc, lin reg. You know what I'm going to do? I'm going to save it as y1. This way, in case you didn't have the actual equation like we do right now, you couldn't type the equation, but you could store it as y1. And you store these things by going to vars, y-vars, and it is a function, y1. There we go. Vars, y-vars, function, y1. Now it's going to give me my 1.52 plus 2.35-ish, right? Okay. Now when you go to stat, edit, for L3, hit enter. And right here, what we get to do is our y hat values, right? Okay, so then we could just say vars, y-vars, function, y1, and hit enter. Oh no, go to. Why'd that fail? I wonder if I could do stat calc lin reg. Hit calculate. Did that do anything? That did nothing. That's unfortunate. How do I get it to generate the y values from my function? Come on. How do I do that? Yes? Second what? Store, second recall? So, okay, so now I do second vars, or no, I do, oh crud. Stat, what is happening right now? Here, hit recall, second store, and then vars, y-vars function, y1, then what? Enter? Oh, okay, true. Nice. Thank you. That's good. So because we stored it, we told it to recall it. All right. Right here, second store. You have to take the x out of the formula and put L2. Wait, L1 I thought. L1, not L2. What did I do? Crud. Clear, enter, kill me. Okay, second, recall, vars, y-vars, function, y1, enter. Come all the way over here, and instead of x, tell it L1. There. That's appropriate. L1, because those are your x's. And we have to put these in as coordinates. Ew. Well, they're gonna have the same x value. So 4 comma 8.418. I'm just putting in the x values so I don't have to think about them every single time. Now I can just write the number 12.97, 17.521. Goodness, this is tedious. There. The residual points, you know what? I'm not writing down all the stinking residual points. I'm just going to write down the residual values. And the residuals are, remember, the difference between the predicted y and the actual y and the predicted y. So the residuals are L2 minus L3. There. So again, I'm just going to write down the residual value. I'm not going to write down the whole coordinate. That's just a pain in the butt. Ooh, this is a big residual. Look at that. Almost 3. That's a big residual. Oh, but then the next one's a -3, so we're still in good shape. I wonder what the sum of the residuals is. It's L2 minus L3 because L1 is x values. I'm just curious. I'm just going to test it out. Second stat, math, sum of L4. I just want to see it. Oh, wow. Look at that number. That is really small. That's really, really small. Wow, cool. Says, record the coefficient of determination. Oh, crud. I didn't read the directions. Record the coefficient of determination. What was it? 0.97-ish. That was r squared. Okay. Find the residual plots. Round to 3 decimals. We did that. Make a residual plot of the data on your graphing calculator. How well does it fit it? Ooh, and how do you know? Okay, well, boop. My residuals was L4, right? And I already have it in my y equals menu. So I'm going to go second stat plot. And for my plot on right here, my x-axis is L1. I want my residuals to be L4. And graph. And why am I only seeing one of them is the real question. Is it because there's... No, that doesn't make any sense. Why am I only seeing one? Oh, because my x values aren't big enough. See? My window. My window needs to go from x equals 0 all the way out to x equals like 32-ish. Boop, there they are. There's no pattern in those, I can tell you that. No pattern at all. How well does the linear function fit the data? Well, that would be a different window, wouldn't it? And let's see. We want our y values to go, how big were our y values? All the way up to like 52-ish? So there's our line of best fit. And if we want these plotted, no, we wanted these plotted, right? I'm going to go to second stat plot. I'm going to turn on another stat plot. Plot 2 will be my L1, L2, my actual XYs. L1, L2, hit graph, and we can see that the line of best fit does a pretty good job with those things, doesn't it? It did a pretty good job. How well does the linear function fit the data? Explain how you know. Well, we know lots of ways. First, we saw that r was close to 1. R squared was close to 1. We know that the sum of residuals was almost 0. And what else? Oh, no pattern to the residual plot. I mean, there was lots of ways we know that we had a good model. Lots and lots and lots. But we've already done this. Why is it in this chapter? It says the table below gives the wavelength and the wave speed of deep ocean waves. Explain why a quadratic function would be expected to fit the data well. Well, how about this? Why don't we find the, let's see, plus 2, plus 2. Oh, we can't use differences because look, we don't have a constant increase on the inputs. So how else could we just say that we're looking at a quadratic? What do you know about quadratics? What are they shaped like? U-shapes, right? Look at the numbers in the wave speeds. Well, not so much inverses. What do we know about U-shaped graphs? They grow really fast. Look at the Y values. They're growing pretty darn fast, aren't they? Do you see it? Or no? So this was like going up 11, almost 11, like up 10, up 14, up 9, up 25. Like this is, and again, you can't, those are all going up by 2 right there, right? So that went up 10-ish, and then up about 15, and then up about 25. It's going 5, 10, 15, 20, 25. The increases are proportional. Not even proportional. The increases follow an arithmetic sequence. So that's how you know that it would fit a quadratic. Or something like that. Anyway, I'm going to find the regression equation. That's more important. Second mem, clear, yes. Okay, everything's cleared. Stat, edit, L1, 3, 5. Stat, edit, 3, 5, 7, 8, 10. Oh, let me do a better job of explaining. Across the plus 2's, look at the differences. We said it was about plus 10, about plus 15, right? And then from 10 to 15, that's plus 5 in the second differences. And then it would have kept it going. So it's looking like we're having a plus 5, which is a constant change in the second differences, which is why we have a quadratic. Second difference is roughly constant. Now we're going to find the quadratic model. Stat, calc, quad regression. Yeah. L1, L2. Do we want to store it? I don't know. I'm going to store it just in case. So let's see. Vars, y vars, function, y1. I'm going to store it just in case. And I'm not going to clear the screen because I have to record r squared. Oops. R squared. Wow. I'm going to take R squared out to 4 decimals. 9996. That's crazy. That's very quadratic. Find the residual plot of the data. Based on the residual plot, could the quadratic function be used to make predictions of deep ocean waves to the nearest meter if this accuracy were necessary? Explain why or why not. Just based on that, I would say yes. I mean, look at this R squared value. That's almost perfect 1. But it does say to find a residual plot. So stat, edit. Now up here for L3, we hit enter, and we're going to do what we did before. We're going to recall it. So second store, and we're going to recall y1, vars, yvars, function, y1. Hit enter. And unfortunately, we have to do this twice, but every time it had an x, that's where we're going to put L1. And then hit enter. There. Are those really our residuals? Oh no, the residuals you have to subtract. I was like, something's not right here. For the residuals, we subtract L2 minus L3. And we were told to find a residual plot. So I'm going to plot L1 versus L4. Second stat plot. I'm going to turn off, or I already have plot 2 turned off, don't I? No, I don't. Let's see. Turn it off. There, plot 2 is off now. So we have to plot 1, L1 versus L4, which is what I wanted. And my window is going to go from 0 to, let's see, how about I take it to 12? And my Y maximums, they should be really, really small. If I remember correctly, they were itty bitty. So I'm going to go -1 to +1. Hit graph. 1, 2, 3, 4, 5. Yep, there's all 5 of them. But remember, my scale, this looks like it blew up. But mine's going by 0.1s. So these are really, really small numbers. Could you use it to find wavelengths to the nearest meter? Of course you could. 1, the R squared value was near 1. 2, they are relatively scattered above and below the x-axis with no pattern. There. Painful.